Once you have doors placed in the model, now it's time to work on the actual configuration of the doors. We'll start with the basics. We're going to use the double door in this example because the double doors will basically have things that are marked 1 and things that are marked 2. This is obviously just for panel 1 and panel 2 in the door. This starts off with sizes. If we go down to the dimensions of the door, you'll see that there is a panel width 1 and a panel width 2 manual. The reason for this is we start off with the assumption that you want panels 1 and 2 to be the same. So if you change panel width 1, you will see that both doors change. And if you change panel 1 again, you will see that both panels change. This way, for situations like the majority of your doors, you won't have to enter the value twice. The panel width 2 manual parameter is activated by checking a box called uneven panels. Once that box is checked, panel 2 is now responding to the second parameter called panel 2 manual. And now you'll see that we can change the size of this panel independently of panel 1. Both panels are naturally using the same height parameter, and so that's listed here, as well as the panel thickness and any panel undercutting that you would like to show. For now, I'll put these back on even panels, and we'll have 2 3-0 doors. Similarly, if we look at this door in 3D, let's assume that we had selected the frames already that we would like. We can do that using the frame door selector. And so maybe in this case, I picked F21 to put a side light on each side. I will stick with the Hollow Metal 1 profile for this demonstration. And I will also pick panel FG using panel 1 selector. Similar to what we looked at with the panel sizes, you'll notice that the panel 1 selector is changing the panels on both doors. If for some reason you have a need to have panel 1 and panel 2 be different, similar to the uneven panels checkbox, you have a panels are different checkbox. If you check that, it then activates the panel 2 selector, and you can now pick something different, such as a louvered panel. Now, you may also want to edit the sizes of your frame. The way the doors ship from Parallax, the frame sizes are all instance-based, and the parameters in the door themselves push down into the frame family and into the frame profile that is driving the frames. So you'll notice that to start, we have a frame head height and a frame jamb width. If you were to go into your user guide, you will find that there is a diagram of these parameters and which area of the door each one is controlling. The simple version is the jamb width will basically control the face width of the door frame. So if you decide you'd like a 1-inch frame instead of a 2-inch frame, changing it will actually make the frame 1 inch. If you'd like the head height to be 4 inches for a masonry wall, you can basically say that you would like the head height to be 4 inches. This means that your door type legends can basically say refer to door schedule, and you don't have to have different details for every different size frame that you have. In addition, if you are doing this in a masonry wall and you've made this door frame 2 inches, but then you need 3/16 of an inch on each side or 3/8 of an inch on each side, you have rough-in jamb additional width and rough-in head additional height. So if you were to put this on 3/8 of an inch, the opening in the wall will get 3/8 of an inch larger than the door itself. It's still room bounding because the family is actually cutting the hole larger, so this will still behave with all of your other Revit functionality. Now, on the interior door, if we leave the frame at 2 inches, in this case, we want our interior frames to inherit the size of the wall plus a normal dimension, which is standardized in the door frames or in the doors as 7/16 inch. This means that if this wall changes to a thicker wall, the door frame will grow with it. The door schedule is also reporting the depth of this frame so that that can be coordinated against your door submittals at a later date. However, it's not always optimal to have the door frame automatically changing with the walls. Exterior walls are a great example. If you have exterior cavity walls or walls that have large framing members or masonry, you might not want the frame to actually cover the entire wall the way normal doors do in Revit. So you have a box that is called frame by throat depth. Unchecking that parameter does what we call breaking the door off of the wall itself. The wall may appear to jump when you uncheck this box. That's because unchecking this box has activated two other parameters that are down in the dimensional section. One of them is frame depth manual, asking you what is the actual size that you would like this frame to be. You'll see here we're at 4 3/4 inch, and we can now change that value to be 5.75 inches, and you'll see it update. In addition, there is also another parameter that is activated now called host push side manual. This is a bit wordy and it can be a bit confusing, but quite simply it means from the Revit host, what is the push side to the door that is manually controlled. This means that you can use this parameter to set your doors properly over the cavity where you'd like them to be seen. For instance, if we make this 8.5 inches, you'll see that we can now get the door frame to cover up the cavity between the CMU and the brick. Realistically, it would probably be more like 7.5 inches, and so we can pull it back. In addition to the frame depth and location in the wall, there is also the frame type, which, as we discussed previously, may be a type that's selected that also includes an intermediate style. You'll notice that when we select F22 Hollow Metal 1, which uses an intermediate style, that the doors do not automatically accommodate. There isn't a way to automatically accommodate this in Revit, so the double doors that have the potential for this have a checkbox called Intermediate Style Exists. If you put that parameter on, you'll notice that the doors will then separate themselves to accommodate the intermediate style. Obviously, if you have this box checked and you do not have an intermediate style frame selected, the door opening will not be what is expected. So that is just something that needs to be coordinated. Very similar to your panel and frame selectors, you also have hardware selectors and hardware options. When you select a door, you'll notice that for each hardware type there is both a yes or no parameter and a selector. The selector is not active unless the checkbox is in play, so in this instance you'll see that the pulls are visible on the door. If we select this, you'll see that the pull box is checked, so the pull that is in use is pull 1. If you uncheck the box, the pulls will go away. Keep in mind that turning off the pull on the door itself means it's gone from all views. So if you're looking to turn off the hardware in a particular view, this is not the way to do it. There are filters and subcategories for the hardware. This is for whether or not you may want to show any hardware on this door at all. There is hardware for door 1 and hardware for door 2, so if you uncheck both pulls, you'll see that both of the door handles on this side will go away. If you then put them back on, you can then change what type of pulls they are. So we can go to vertical continuous and vertical continuous, and you'll see that we will get vertical continuous pulls. Similarly, we can take this door and activate the closers on each side and the kick plates on the push side of each panel. and a lock set on panel 1. And you will see that all of those items have shown up now. In addition to the different types of hardware, the doors also have provisions for accessibility clearances. The first step to turning on accessibility clearances is saying, I would like to show ADA clearances for this door. You'll notice that the Parallax components all say items exist for this door. Keep in mind that's because this is not a visibility setting. There are filters and subcategories for the clearances. This means globally, do you want there to be a clearance on this door, yes or no? On the single doors, simply checking that box that says ADA clearances exist is enough to make the clearance show up. On double doors, however, that can have uneven panels, you then have to declare which panel or both would you like to show the clearances on. And when you check that box, you'll see that the ADA clearances start to show up. The ADA clearances themselves also have type selectors. There is the pull side and the push side of the door, and so that you can pick which clearance is used on each side. So for instance, on the pull side of the door, we are using a clearance that is made for a swinging door. On the pull side, it's a front approach that has less than 8 inches of recess of the door. There are other swing sides you can use, such as hinge side approach passing the door, and you'll see that the clearance will change size. Specific names of the clearances may change between offices, particularly as these doors undergo customization. So you may want to consult with your internal documentation or your BIM manager for how these clearances work. Certain types of drawings also benefit from having the ADA clearances hatched, and so you will notice that there is also an ADA clearance hatch visible parameter, which actually adds in a hatch to the rectangles that you see here for the clearances. Once the parameter is checked for the hatch to be visible, it's then just a matter of having a view template that allows for you to see that subcategory. It's called Clearance Accessibility Hatch. This accessibility hatch is actually modeled in 3D, as it's the only way to get the nested families to respond correctly and show the graphics that we want. We'll get into how to control graphics specifically in one of the later videos. The doors also have options for movement of the panels both in 2D and 3D. For clarity in the video, we'll turn off the ADA clearances on the door. You'll notice that there is a plan representation which is done as model lines in the Parallax door library, and you'll notice that the panels themselves are modeled closed. If you're doing any work in rendering or VR and you'd like the doors to be open, you do have similar options. You have panel angles in plan, and you also have panel angles in the model. So in the model, you can set the doors to be open 50 degrees, and you'll see that they do open. They take all of the hardware with them, including the closers, the pulls, the pushes, the kick plates, and the lock sets. You should be able to open most of the doors up to 180 degrees should you need to. You'll notice that on the swing doors, the way you open them is with an angle. Sliding doors will use a percentage, and so will overhead doors. Now, this is different than the graphics that are used for plan. In plan, you are using the parameter called panel 1 angle in plan. Similar to other functionality in the doors, the panel 1 parameter is actually going to control both panels, unless you have a distinct need to make the panels separate, at which point there is a parameter called separate panel swings in plan. Checking that box, similar to the other functionality in the doors, will now allow the two panels to act independently. This is especially handy if you have a double door that's getting installed where one door is getting locked for some reason. In that case, you can set panel 1 to 90, you can set panel 2 to 0, and it will show panel 2 as closed. Similarly, if you have doors that are close to each other at the corner of two rooms and you simply don't want them to be hitting each other in plan because it's ugly, You can have the doors open 45 degrees in plan so that the graphics are not overlapping one another. You'll also find, if you set your project to realistic mode, that the doors are coming in with a render asset that is fairly generic, but glazing comes in as glazing, metal comes in as metal, and if we were to switch the panel of these doors to one of the E wood panels, you'll see that they will get a render asset that looks like wood. These render assets on the materials are set at the panel type and frame type level. They can then be overridden by what we call finish parameters that are instance parameters of the door. So the wood panel gets its wood realistic texture based on the type property of this panel, which is called openings wood. However, if in your renderings you would like to show it painted or stained another color, you can simply go to Panel Finish 1 and pick a material that's in your project. For instance, if I use just this generic demolition material, you'll see that Panel Finish 1 now overrides the wood material, and the doors are now painted that color. That's actually a ridiculous material because we use it just for showing demolition, so that wasn't a great example. If we go to red, you'll see that we have now painted the doors red. There are 3 finishes, 4 panels. Panel Finish 1 will always be the main body of the panel. Not all doors will use Panel Finish 2 or Panel Finish 3. You'll have to consult the door guide for which panels use Finish 2 and Finish 3. More than likely, it will be things like glazed panels, where material 2 will then be the glazing. More intricate panels that have multiple materials on them may also make use of Finish 3. So in this case, you're seeing that Panel Finish 1 affects the main body of the panel, and Panel Finish 2 would be for the glazing itself. So any film or render appearance that you want to show of the glazing, you could actually change in Panel Finish 2. The frames are similar. Frame Finish 1 will always be for the body of the frame. So if you wanted to also paint the frame red, you could change Frame Finish 1 to be red, and your whole door will be painted. Keep in mind, for this demonstration, I'm using a generic material called Fire Extinguisher Cabinet Metal Red. Consult your internal naming strategy for what material names you want to use for painting your doors. As you may have noticed by now, all of the graphics for plan and elevation views in the Parallax libraries are done with model lines. This is done so that when you're in a view that's not looking straight on at the components, you can still see the symbolic lines properly. If you wish to not see these for things like rendered views, what you can do is go to your view template or visibility graphics settings, and you can turn off those subcategories. So as we look at this door, you'll see both the plan swing and elevation swing lines. And if we go into visibility graphics under doors, you'll see that there is plan swing and elevation swing lines. Yours will only have the versions that are in capital letters. The other ones are for other content that are in the Parallax template, and you won't have to see those. So if you turn off the graphics elevation and graphics plan swing, you'll see that those lines will then go away. Similarly, you can also use subcategories if you have a particular need to turn off either door panels or door frames or door hardware. It's not required to turn off door hardware in this way, since there is also a door hardware filter. So it's up to you if you are hiding it globally or if you just want to turn it off, and which way you're more comfortable working or how your project has been set up. But you can defeat things like door hardware through object styles or filters as well. The model lines that you see in 3D that show up in plan for the door swings also have an offset parameter that is generally set to 2 inches. The reason for this offset is if you are a firm that uses either floors or roofs to model in your finishes, we don't want the model lines to be covered up. So if we model in a floor for the finish of this room, we know that this finish is now going to sit above the level 1 slab. We then want to make sure that if we go to a floor pattern plan, where that VCT shows up, that the door's symbology is still on top of that finished floor. That's done because the door has an offset set to 2 inches currently. So if you are in your perspective or 3D views and you happen to notice that the lines themselves are above the door, that would be why. You'll see them here. If you want to lower it, you can simply select the door and change the instance parameter. I keep them on 2 inches as that is generally higher than most finishes that get placed in architectural models. This covers the basics for configuring most of the typical doors that get placed in walls. There will be another video that goes over specific curtain wall configurations, but most of the configurations are actually very similar to the wall-hosted door. Parameter sizes and things of that nature are very similar, and we'll cover the differences shortly in the other video. One last thing to keep in mind is that not all doors will have all of the same options for their parameters. For instance, the commercial sliders, which are meant to represent pre-configured manufacturers' options for telescoping and biparting doors, will only have a checkbox for center the frame on the wall thickness. They will not have a parameter for manually setting the frame depth because the depth of this frame is actually set by this unit, which you could get from the manufacturer's cut sheet. Similarly, you'll notice that this door does not have panel and frame type selectors available in the instance properties, since all of that is set in the type properties because these are very specific frames and panels meant to show this specific door. Similarly, a standard double egress door relies on having this particular frame. In addition, we like this door to come in by default with the vision light panels instead of the solid flush panel, since these doors should have vision lights so that you can see through them to see who's behind the door. So because of that, this door does have options for the frame type and panel type to be used, but those options are moved to the type parameters because we want to keep them pre-configured like so. As you move through the door library, you'll see that all of the options are similar, and the doors all use the same parameter structure and naming, but doors that are missing certain parameters is generally because those options are not intended to be changed in those doors. This wraps up the general how-to in configuring the normal wall-hosted doors. Our next video will go over the specific differences for the curtain wall versions.